In this last video about monopoly, I want to talk about markup as the measure of the monopoly power. So let's see how it works out. We will start with the solution to the monopoly problem in my example that I've been developing in the previous videos. The monopoly will maximize the profit when quantity equals 10, price equals 90, and marginal revenue and marginal cost equal to each other and to $60. So first of all, knowing the demand function, you can actually establish a relationship between price and the marginal revenue. So I'm going to introduce this new formula that suggests that at every point on the demand function, marginal revenue equals the price adjusted by a term equal to 1 plus 1 over the elasticity value, where elasticity is the own price elasticity of demand, which should be a negative number. So let's check that formula just to illustrate it. Let's check it for quantity equal to 10. Recall that if we wanted to calculate the elasticity, we can use the point elasticity formula that suggests that elasticity is the slope multiplied by the price and divided by the quantity. And for the slope, we need to take the slope from the demand function, not the inverse demand function. So we need to take the coefficient in front of the price from the demand function. So that will give us elasticity equal to slope of negative 1/3 times the price of 90 divided by the quantity of 10. So 90 over 10 is 9, multiplied by a third should give us 3. So elasticity will be negative 3 at the point where the monopoly maximizes its profit. So let's plug the elasticity of negative 3 into the formula. Price times 1 plus 1 over the elasticity. Price is 90. 1 plus 1 over the elasticity is 1 plus 1 over negative 3. So that's going to be 90 times 2/3. And that exactly equals 60. So you can see, using this example, that the formula works. Marginal revenue is price adjusted by a specific elasticity equation. Why do we care so much about this relationship? I'm going to copy it on the next slide. Marginal revenue is price adjusted by 1 plus the inverse of the elasticity number. The reason that we care so much about it is that in practical decision making that you might encounter, you might not know the whole demand curve. You might not have the equation for the demand line, because sometimes what you're given as inputs is just, well, the marginal cost of your production, and then just the elasticity of demand, because the whole demand curve is more difficult to estimate than its elasticity. And so suppose you're given the following problem. You know that it costs $60 to produce an additional unit of output at your current rate of production, and you also estimate that your demand has elasticity of negative 4. What price should you charge to maximize profits? And so here's where we're going to combine the two facts that we've discussed so far. One fact would be that to maximize profits, you want to set marginal revenue equal to marginal cost. Just like in the monopoly problem, to maximize profits, marginal revenue has to equal marginal cost. But secondly, you know the relationship between marginal revenue and the price. So now you have a relationship between the marginal cost, which is given to you as an input, the elasticity of demand, which is also given to you as an input. And you can select the price such that the marginal revenue at that price, given the elasticity of demand that you've estimated, exactly equals the marginal cost of your production. So here I'm going to write it down. The price has to equal marginal cost divided by this elasticity term that we use to adjust the price for to obtain the marginal revenue. So let's check out how that's going to work. If elasticity is negative 4, 1 plus 1 over the elasticity is going to be 3/4, and so you need to divide your marginal cost by 3/4 to get the price of 80. So this is kind of a rule of thumb. If you know the elasticity and you know your marginal cost, you can identify the optimal price just given these two values. Let's see how that optimal price depends on the elasticity. So here I'm looking at, say, 3 different markets, and in each of the markets, the marginal cost is 60, but they differ by their elasticity. Negative 2.5 in the first case, negative 3 in the second case, and negative 4 in the last case. We just calculated the optimal price for the last case. That price is going to be 80. For the case of elasticity of negative 3, that's the case from the previous example, and we know that the price here is going to be 90. And then you can pause the video and calculate the optimal price for the last example with elasticity of negative 2.5. And I'm going to show you the answers right now. So you can see that depending on elasticity, your optimal price will be different. It's going to be 100 when elasticity is negative 2.5, 90 with elasticity of negative 3, 80 with elasticity of negative 4. So you can see that the more elastic your demand becomes, so the higher the number in absolute terms for the elasticity, the closer the optimal price is going to be to your marginal cost. So if your demand is particularly inelastic, relatively inelastic, that means that your product has fewer substitutes. Because what does it mean for demand to be elastic? You change the price slightly and your customers run away to your competitors. If your demand is inelastic, that happens less so than if your demand were elastic. And so if your demand is relatively inelastic, a spike in the price will not cause much of a change in quantity demanded. And so you can charge a larger price relative to your marginal cost. Now, given that we know the optimal price and given that we know the marginal cost of production, we can calculate another measure of competitiveness in the market. So we already know that elasticity of demand can be interpreted as a measure of competitiveness. The more elastic the demand is, the more competitive the industry. Recall that in the extreme case of perfect competition, the demand is perfectly elastic, which corresponds to the elasticity of negative infinity. Well, I mean, think about it as, say, negative 100 rather than negative 2.5. So now what we can calculate is a measure that's called markup, which is basically the ratio of the excess of the price over the marginal cost by the marginal cost. So it calculates how much over the marginal cost we're charging in terms of the price. And so if we wanted to calculate the markup, take the price, subtract the marginal cost, and divide it by the marginal cost. Again, you can pause the video and do the calculation on your own. But the markups would be as follows. 0.67 in the first case, 0.5 in the second case, 0.33 in the last case. What does the markup stand for? It can be interpreted as follows. In the first example, in the first market, we're charging 67% above the marginal cost. In the second example, it's 50%. The optimal price is 50% above the marginal cost. In the last example, it's only 33% above the marginal cost. So you can think of the markup as a measure of market power of a company in the market, because if you recall, under perfect competition, the companies are forced to price exactly at the marginal cost, so the markup in a perfectly competitive market is 0. So the closer the markup is to 0, the more competition there is in the market, and conversely, the less market power there is for a company. So a company that is able to have a markup of, say, 2.5 is a company that has a ton of market power and does not see a lot of competition in its industry. Whereas a company with a markup of, say, 0.1 or 0.2 faces a ton of competition and does not have a ton of market power. And so it's a helpful rule of thumb using elasticity to identify the optimal price, and also a helpful formula to see how much over the marginal cost the company can charge to see how much market power it has. All right, thank you.